Find the power in horsepower for a 12-inch impeller pump. In this problem, the pump curve for a 10-inch impeller pump is provided. Crude oil is pumped at a constant speed for both size pumps, and the efficiency for the 10-inch impeller pump is given. The system curve and associated diameter are also provided. In this problem, our strategy will be to find the required pump power for the 10-inch impeller pump, then find the required pump power for the 12-inch impeller pump. This equation for power in horsepower requires the units of head to be in feet, the units of flow rate to be in cubic feet per second, and the efficiency to be a decimal. Conveniently, the pump curve already uses the units of feet and cubic feet per second along the head and flow rate axes, respectively. To find the head and flow rate at which the pump operates, we need to examine the system curve. We notice the static head is 50 feet, and as the velocity through the pipe increases, the head increases along a quadratic, which we still need to determine. Since the horizontal axis of the plot is the flow rate, we will modify the system curve equation such that the head is a function of the flow rate. Since the velocity equals flow rate divided by area, and we know the pipe diameter is 24 inches, we convert inches to feet, solve for the area, and plug the area into our equation for velocity. Substituting 0.3183 times the flow rate in for velocity, the system curve equation is 50 feet plus 2.083 times the flow rate in cubic feet per second, squared. If we plot this equation, the system curve intersects the pump curve at a flow rate of 12 cubic feet per second and a head of 350 feet. With the known flow rate and head, we'll return to the power equation and plug in the head, the flow rate, and the efficiency as a decimal. The specific gravity of crude is equal to the density of crude oil divided by the density of water. The density of crude oil equals 51.14 pounds mass per cubic foot, although this number may be slightly different depending on the temperature and other properties of the crude. Plugging in the specific gravity of 0.82, the power required by the 10-inch impeller pump equals 583.2 horsepower. Using the affinity laws for a constant speed motor, the ratio of the power required for two pumps is equal to the ratio of the impeller length cubed. Since we're looking for the power required by a 12-inch impeller pump, the equation is rewritten to solve for P sub 2. Plugging in the three known values, the power required equals 1007 horsepower. When reviewing the possible solutions, the answer is D.